So this is going to review how to interpret the slope and the y-intercept of a regression line in statistics. So you probably remember a linear equation, the formula for a linear equation, y equals mx plus b from algebra, and the stats regression line looks really similar. So in algebra, the m here is your slope. What is the rate of change in your graph? And in stats, that is represented by the letter B. You can see that this is mx and this is bx. So that is one way to remember that represents your change in your x value. The other letter here in algebra, B represents your y-intercept. And in a regression line, that is the letter A. So don't get confused and think B and B. Look at what it's with. MX and BX, those are similar. B is by itself and A is by itself. That is your starting point. That's your y-intercept. And here we have y and y hat, literally y hat. And this is your y value. And this is your predicted y value. So our equations here are super similar. And as we go through the examples, you'll be able to see how to use them. So this scatter plot shows the relationship between the number of slices of pizza eaten by each member of a football team and the number of laps around the block the player could run immediately after. The equation of the regression line is shown in the graph. Y hat equals 10 minus 0.67x. So whenever I get a graph, the first thing I want to think about is like, what is happening? Either from the text or from the graph. This graph is about number of slices and number of laps. So what do you see happening with this line? What do you think is happening? Well, I see it's negative. And that means like as the number of slices increase, the number of laps decrease, which makes sense. When I eat more, I don't want to run as much as I can before. So I think this represents the more pizza you eat, the less you run. And that's where we're really going to start to think about how to interpret this. We're going to look at our explanatory and our response variables. My explanatory is my x, my predictor here. As the number of slices increase, the number of laps decreases. So really all I'm filling in here is my explanatory, my response, and the direction. So that's what's happening in general. Let's think specifically about the slope here. And in algebra, you might see slopes like m equals 2 over 4 or m equals 5 over 7x. It's okay if we had something like this, where we had a fraction. But in stats, we're going to focus on the bottom number being 1, on our change in x only being 1. So we have our change in y over our change in x. And here, this is always going to be 1. Because I want to know for each additional 1 unit, what happens to y. So for each additional 1 pizza slice eaten, our model predicts that the number of laps will decrease by 0.067. I know that from looking at my slope here. My slope is negative 0.67. And that negative is important. It represents that this line is going down. It's decreasing. They are running less. So when I want to interpret this, I look at my slope. And I know that is the change in the response variable for every one additional explanatory variable. So for every one additional pizza slice eaten, let me do it from here. Every one, it goes down by 0.67. For every one, down 0.67. Every one, down 0.67. So how can I interpret the y-intercept? The y-intercept here is 10. And I can see that on the graph, that is where it intersects the y-axis. So what does this represent? This represents when the number of slices is equal to 0. And that makes sense because here is 0. And so, and I think about, well, like, what does that mean? That means most of the football players, this is the football team, most of the football players can run, we predict they can run 10 laps if they have not eaten. So I predict, I'm going to change that to I. I predict, or my model predicts, the line predicts. I predict that a football player can run 10 laps with no pizza eaten, or when they have eaten 0 slices of pizza. Let's look at an example here. I have my y hat, which is my predicted. That means I am going to predict. I'm not 100% sure because there are some points above and below the line. I know that this is my y-intercept. That is my starting value, my value when x equals 0. And then I have my slope. Already I can see that my slope is positive, which means my graph is going up, my line is going up. My y-intercept is 180.8, which makes sense. Yeah, that line should go a little bit up there, which makes sense there. And it looks, right, like it's going up about 15 each one. Okay, so what does this mean? This is about sugar and freshness. This is actually about flowers. And when you add sugar to flowers, to the water in flowers, it makes it fresh longer. So we can say for every 1 additional tablespoon of sugar, so I'm using for every 1 additional explanatory value, the model predicts, and the model is your equation or your line. The model predicts an increase because my slope is positive and the line is going up, an increase of 15.8 an increase of 15.8 hours of freshness. So thinking for every 1 additional tablespoon of sugar, the model predicts an increase because it's positive and it goes up of 15.8 hours of freshness. 15.8 hours of freshness.